Hey Vin, what's up?
How's it going? Thanks for having me.
Yeah, of course, of course. So we have a Vin Vashishta from V Squared Consulting. For those who don't know who you are, why don't you give a quick intro?
Um, wow. 25 years in every time I do this intro, I feel old. 25 years in tech and spent the last almost 11 now years in data science, machine learning, BI, analytics, all of the we called it data science, but it really wasn't. And then we
Hmm.
kind of were doing data science and we really weren't. And now we're doing machine learning and most of it works. So I would say the last 11 years of my career has been doing various incarnations of data science that a lot of it's worked really really well even when it was very very basic back in the early 2010s 2012s, and that's where I learned more of the practical and applied side of it. I started out trying to get into artificial intelligence back in the 90s and
Oh,
graduated early. I got that first wave that didn't crest. It just kind of fell apart. And so I went into the corporate world and learned a lot of really good practical lessons. And that's, fast forward to 2012, 2013. And I was actually building with data and building products, throwing things out there that were efficiency type projects where companies were saving money. And that's what I came up in, is really this applied side. And now I do applied research as well. I do a lot of work with strategy, helping companies with product strategy, monetization, trying to figure out, okay, you've deployed it in production. Now, how are you going to get paid? Because that a lot of companies are starting to realize it's not the same thing. Just because you deploy something doesn't mean you're actually making money with it. And just because customers are paying for it doesn't mean that throwing a machine learning based feature was actually worth it. So that's kind of been the last 6 years of my career, has been steering the ship back towards cash and helping companies that are rightfully greedy try to make as much money as they can off of models and inference, and teaching companies that if your customers aren't paying for inference, then that machine learning model doesn't really do anything. I mean, it's a nice UI.
that's awesome. This brings up a really good question too. I guess where I think we have very similar backgrounds in a lot of regards with just watching companies sort of get some success with machine learning, others maybe not so successful. I mean, what are the patterns for companies that have been successful with machine learning, and I guess as you put it, making money off of machine learning?
I see two groups. One gets lucky, and there's been, and that's perfectly valid. I know it sounds diminutive, but it isn't. Sometimes you can have a product go out that's machine learning based, and it actually ends up being a valuable model, where the model itself is what customers end up paying for, and you realize all the head, front end type of stuff that you put on the service and the inference is really just kind of window dressing. And you could sell the service by itself. You could sort of sell access to the inference. And so they get lucky with that. And they come to the realization almost immediately that all the other work that they put into it, they can kind of strip away. And then there's a pricing model there where you can charge for it to look pretty or be easier to access or have more features for more users. And they luck into that realization that you have to start with inference, get people to pay for that. And once they're hooked on that actual inference that they're getting from your models, typically a lot of them, then you start adding on features and you make it into sort of a more traditional software product where the software supports the model rather than the other way around. Other companies have a whole lot of stumbles where they released a software product with a model in there. And the model doesn't really do anything that you couldn't have hard coded. You couldn't have, just used logic or used like an expert systems approach and gotten the exact same value for your customers or exact same cost savings for your company. And through several iterations of deep learning that really results in analytics, the process starts by someone coming in and doing an evaluation and saying, look, this doesn't really work. And a lot of times they'll hire someone new. They'll hire somebody that's worked at a different company or a competitor who's had more success. And that one person will come in and just start saying, look, that doesn't work. That doesn't work. That doesn't work. And I've seen both of those. Like I said, the luck approach and the trial and error, and then bringing in expertise and having someone really, once you've stubbed your toe enough times, you're ready to try something different. And that person comes in with good timing and says, well, I can tell you what's wrong, and here's how to fix it, and here's maybe some things that we should be doing differently. And then I see companies sort of going towards success at that point. But there's a lot of companies right now that just haven't hurt enough. There's not enough pain. They think they're making money, and there's no reason to doubt it. So, why fix what they don't think is broken?
Interesting. Are you kind of hinting that there's like kind of some ML theater then?
Oh yeah, and I think all of us are guilty of it too. I look back on my career and I look at some of the stuff, like I said in my intro, back, looking at 2014, I did some expensive analytics back then. I did some really, really expensive analytics. And obviously now looking back on it, I've got more experience in the field and I understand that machine learning can produce analytics. And it's the worst way to go in a lot of cases.
Hmm.
But yeah, there's a lot of hand waving, and a lot of the time the people who are pitching you the product don't understand data science, or the people that are pitching you the project internally don't understand data science or machine learning, and they've had to have sort of the project explained to them through three coffee filters. And what ends up getting pitched to the CEO is, it's not the same thing. And then the CEO has a different expectation of what's going to happen. The business unit that will have to use it or will have to sell it, market it, has a different expectation of what's going to happen. Maybe the customers, if it's a B2C, the customers that are going to touch the product have a different expectation of what's going to happen. And then that gets in a requirements document and goes back to the data scientist. And now they're stuck with theater. Like they started out with a totally legit project that was going to do some amazing things and be really, really simple and take 6 months to get out the door. And now they have this thing that now it's theater. I mean, you're stuck with it. You have now been given the requirements. And so I think all of us are guilty of theaters. So I don't want to, point the finger at everyone else and say, oh, it's all everyone's fault. But there are some companies that are definitely doing it intentionally. There's some intentional theater out there and hype out there. But in a lot of cases, data science teams get backed into that corner.
Yeah, that's interesting. And you mentioned hype too. I mean, do you feel like, I mean, I think we both noticed probably around, you mentioned 2014, and there's sort of an area, I think, from 2014 to maybe 2013, whatever, up to maybe even the last year, where the hype cycle was just like, it's just red hot about ML. And now, I don't know, what's your take? Do you feel like people are becoming more realistic, or do you still see the kind of glowing red hot hype cycle continuing with ML and AI?
So I see the hype cycle's moving on to small and mid-sized businesses now. And so your larger companies or your more machine learning first companies have sort of figured it out. And they started figuring it out. I saw them start figuring it out back in 2015, 2016.
Mm-hmm.
That's when larger companies began to understand what machine learning first meant for a business model. And there was this kind of amorphous concept of business model innovation that started showing up in a whole lot of people's presentations alongside of machine learning. And so they said, okay, so we're going to have to build a business model. That means revenue, and all of a sudden this more traditional strategy business focus came into play with some very large companies. And I think that's happening with more and more companies now, which is why it feels like the hype cycle's dying down, because more mature companies now have gone through a couple of iterations. They're now looking at the business model more critically and saying, okay, not every problem is a technology problem. Some problems are a business model problem. And if we switch the business model, or if we spin off new business models, we can take advantage of this technology a whole lot better than we are right now. And so I think that's killing some of the hype, because businesses are now driving it, saying, okay, here's my business model. Here are my short-term, mid-term, long-term needs. Here's your product roadmap. And it's a whole lot more structured. And that kills hype, because companies can't come in, your software vendors and your IT services companies can't come in. Accenture can't steamroller you at that point, because you have this thing and you're like, no, this is what you're building, guys. You can either do it or you can't. And so a lot of companies are moving away from hype, but small and mid-sized businesses, that larger, wider market, they're getting like the wave two hype 2.0. And, the salespeople are way better than they were in 2015 and 2016. The products work a little bit better too. So they're more promising. There's more feature sort of fullness. And so I think I'm seeing like the second round of hype hitting the small and mid-sized businesses. Some are very much unsavvy about what they're getting sold versus what they're expecting to be able to do with it. And there's a lot of money that's going to end up being wasted. There's going to be a whole lot of iteration time. And I mean, what's sad about small and mid-sized businesses is they don't have a whole lot of time to catch up. And so if they're adopting the wrong technology, or if they don't really know how to use it, I mean, some of them are going to go out of business because they choose the wrong vendor. And that's just, I feel bad about that because that's some negative hype. It's really some bad side effects of this hype.
Because what additional challenges do you think a small and medium-sized business has as compared to, the larger businesses that have successfully adopted AI?
I think from a small business perspective, you can't attract talent as easily. So you're not going to be able to pull somebody in who's going to be able to sit down with you and say, okay, that's garbage. You don't want that. These are the things that you want to actually adopt. And so getting that expertise that will guide you in the right direction, getting some high quality machine learning engineers or data scientists, or even, the product management side of it, getting a good ML product manager, it's going to be hard for a small and mid-sized business to attract that kind of talent. So it's going to be hit and miss whether the business has the right people in place. And also, they can't afford to make a whole lot of mistakes. Like I alluded to earlier, they don't have the time to catch up, and they also don't have the budget to really recover and just say, we spent 25 million on it last year. It was a dead end. Bummer. Let's just go for, they can't do that. They're sort of stuck at some point with imperfect solutions. There's some challenges there. It's really more important to get it right the first time if you're a small and mid-sized business, or quickly iterate and learn from mistakes as a small and mid-sized business, than it is for a large company that can, where they were already ahead of the curve and they can just spend their way out of problems.
Yeah, it's interesting. For those small and medium businesses too, like, are there certain classes of machine learning problems that they should be adopting first before others, or how would these companies even begin to think about adopting machine learning in a way that's not going to kill them?
I think it's business case driven, and the first few projects have to be simplistic but high impact. And that's why I say, the talent part's really critical, because having someone who can dictate which projects those are, how those are going to work, and then just even building a product roadmap with a machine learning product at the core of a product roadmap is tough. So that's the big piece of this, is trying to get that started and trying to have some idea of what product can really help the business the most, what can generate revenue rather quickly so that the machine learning group can grow without becoming a cost center. So the expense of what you're going to have to do, how much infrastructure to support this is going to end up costing. So to have a hit right off the bat, so that you're not dealing with that stigma of being a cost center a year from now, that's huge. And like I said, it's really knowledge driven, trying to figure out what's that product going to be. What does the business model support now? What do the customers support now? What can we, what space, sometimes what market can we extend out into, or what categories can we define? Those are tough questions for small and mid-sized businesses to answer.
Mm-hmm. And you bring up the talent gap too, which I see a lot, where there's not a lot of good machine learning help out there right now. I think there's a lot of data scientists, but that doesn't mean you're doing production ML, right? So,
Yeah.
How can these companies begin to even consider addressing the skills gap? Because it seems like it's going to be a pretty major problem.
Internal, train up, get a good farm system. And I talk about it like a baseball team. It really is. Get a good farm club, get a training program in place, and start bringing in a pipeline of talent. Look around your company, and you're going to find people that are 1 to 2 years away from being, a data scientist, or being someone who can push a model into production, support a model, do the testing side and the validation side of it, who can be a product manager, who can train into the product management role and start actually, getting that money attached to a model. So you're gonna find in a company the fastest way to do this, especially in small and mid-sized businesses, is just start training people up. really build that pipeline of talent, and spend the money to get a couple of people in the door and be serious about it. Don't say we're doing machine learning, but be serious about it. Be real about it. What is it going to take in order to do this? And it's not a huge investment compared to faking it, which is, and I don't mean faking it again in a diminutive way, but a lot of times companies say we're going to do machine learning and then they go about halfway. They really mean, well, we're going to dip our toes in the water. For a small and mid-sized business to spend that amount of money, they have to see the value, and it's going to cost money. It's going to take time. Large parts of the company, not the whole thing, but large parts of the company are going to have to participate in this process. So to get the talent to show up, to get, 2 or 3 really high quality data scientists, machine learning engineer, and someone who has pushed models into production and make money that people are actually paying for, not that are just spinning, CPU time. That takes not only the cash to bring them in, but also the projects. The company has to truly be interested in order for that person to become interested. And in that way, small and mid-sized businesses have an advantage in getting talent because their projects are going to be way more exciting, are going to allow for a better product outcome for an individual. So instead of working on this massive team where your impact is, this one little box, in a small company, you're going to be on a team of maybe 3, maybe 5 tops. In some cases, you're solo, and your impact on the business and on that product and your control is so much higher that if the business is serious about it, they have an advantage attracting talent, because that's the exciting stuff. That's the stuff we all want to work on.
Mm-hmm. Interesting. What are your thoughts on, not going to name any names, but tools that are geared towards the citizen data scientist?
I think they're awesome. I think they're scary. So awesome because they make analytics really, really easy to understand. So analytics by themselves, it kind of gets packaged like if I give you a dashboard, you're cool. And you're not. As a business user, you're really not. It's like a great dashboard, colorful, but what does it mean? Thanks for the numbers. Don't make me interpret this. Mm-hmm. And so the self-serve stuff's awesome because it can help them understand how to interpret and then use data to support their interpretations. That's the awesome side of self-service. The really scary side of self-service is when a product says you can do data science work, because no, you can't. You can support your opinion. However, that opinion is still an opinion. It hasn't been proven yet. You can't overextend it. Analytics, that's not a predictive model. You can't make a prediction based on the data. You can make it based on your opinion. But you have to remember to say that. This is my opinion, and here's why I think it. Has it been proven? No. And self-service doesn't do that has it been proven part. But it often gets overextended by people that are selling their products to say, oh, yeah, no, these are great predictive models. As soon as I hear this, nope, you can't do self-service predictive. Nope, that doesn't work. Prescriptive. Nope, you can't say that. But they do. And that's the biggest problem. That's what's scary about it.
I think as you alluded to earlier, too, the salespeople for a lot of these solutions, they're better than they were.
Oh, yeah.
You got like AI snake oil salesperson 2.0 as well to go along with the hype cycle, right? So this is going to be interesting because, yeah, I do agree with your assessment of like kind of SMB and where they sit, because a lot of these companies are kind of sitting ducks right now for these sales guys to come in and seal the deals, as they say. So,
oh yeah, and the companies don't have the institutional knowledge to understand whether they're being sold something that's working, mm-hmm. whether they're being sold something that will work for them, or whether they're being sold something that will, in a very short amount of time, become obsolete. And there are all of those kind of potholes, and you've seen it too. A company will, it sounds great, looks great on paper. It worked for 4 other companies that were similar, but it doesn't work for them. And having that institutional knowledge, it's really tough. Even knowing the field it's really tough to assess tools and try to build an architecture that'll support everything that you're going to need for the next 5 years. It's hard.
Yeah, well, and we're just talking about too, like kind of the off the shelf, you know, data scientist in a box tools. Not even talking about the ML ops space yet, which I'm sure we'll talk about in a sec. But yeah, it's confusing enough. I mean, there's a lot of companies that, and a lot of open source projects too. I think purporting
Yeah.
to sort of come and save the day. And yeah, in some cases maybe you get some leverage out of it. But yeah, to your point, it's like you gotta have the institutional knowledge, and that just comes through hard work. Like you're not just going to tack on, whatever product and magically transform your business. I mean, if it's that easy, everyone would be doing it, and it's actually be a solved problem, right? So,
And everybody's CEO would be happy about it, and they're not.
mhm.
That's
Right.
one thing I'm seeing increasingly is people at the very top auditing budgets and just going, "You're going to have to prove it this year."
Hmm.
I'm not just rubber stamping buying more stuff. You're going to have to prove it this year. Most companies don't know how to do that. A lot of data science teams don't know how to do that.
How do you go about proving it?
Well, you have to connect business metrics to your project metrics, your machine learning model metrics. Just make the connection. There's, the machine learning product manager. That's the whole reason why you need that person, because they can do that. They can be the connection between the strategy side of the house and the business numbers side of the house and machine learning model metrics. Like your model should be a representation of some business system. It should be representative of something that's happening either within the business or for the customer. It should model something. And that gets lost. Like, what is it really modeling? How does that impact the business? That's how you prove it, is you are able to connect those two metrics repeatably. And now you're communicating to the business in business terms instead of in, well, we've got these accuracy numbers. We're looking at model performance and you're throwing out these numbers that sound amazing, but they're not amazing in the way that the business needs them to be. And so it gets into production and it makes money, but it doesn't make as much money as it should. And so projections are unreliable. The company doesn't want to put its name behind any sort of, well, we think this machine learning model is going to make X amount of money. Like they just won't say that because they're not confident in it.
Hmm.
And they haven't made that connection yet. And so it's difficult to prove until you have that connection. And once you do, then all of a sudden everything just starts working because money starts flowing in. Things either underperform, perform, or outperform. And then you can do that analysis. Like, why did this project underperform? We thought these were connected and turns out they're not. So we've learned something. So yeah, maybe that project did not succeed in the way that we anticipated it. However, we're now learning from our mistakes instead of just going, I don't know why that happened.
Interesting. I guess for companies that are considering going to the cloud, do you have any recommendations for how they should get started with machine learning in the cloud?
I get scared when a company wants to throw everything machine learning into the cloud because I think you need to control some things. And I think that's because we've got regulatory concerns coming. So putting all data in the cloud can, in some cases, make regulatory concerns difficult. Um, Cloud migration isn't for everyone. I mean, do you really need that much horsepower? Is it because you've built a really bad model that you need all this horsepower to cover up the fact that it's really not that good? Have you featured it to death? Have you put in 2 trillion layers when obviously not that many, but have you put in all of these layers and you needed 4, and instead you went, you went to the beach and back and decided to throw everything in the middle? And that's usually what I find when I find models in production that are chewing horsepower that would require really pushing it out to the cloud. I started asking the question, like, why is it so big? Why
Hmm.
are you serious? That many features? This is this complex of a system? Really? You're modeling something that's this complex? Because I've seen like models for what happens inside of fusion reactions that are less complicated than this one. So are you really sure that we need this level of complexity? And that's kind of the example that I'll typically use. I'll say, okay, so you're going to the cloud, so things are really complex, huh? So we're using a lot of horsepower, huh? Why? And that starts a better conversation around why and what goes to the cloud, and maybe what do we keep, what should stay in house, what doesn't necessarily need to be offloaded out. Once you can kind of justify, and you have this process of justifying, this needs to go to the cloud because here's an advantage. Like, this is way better than keeping it in house. Here's how much it would cost to continue to run this on my laptop. And all of a sudden you're having tangible conversations about value instead of cloudy with a chance of, snow.
So for companies starting in house, do you recommend they start out just hacking on their laptops, or like what's a
Yeah,
setup
why
that you
not?
would? Okay.
Run it on your laptop. You're going to find out really quick that you need to make things smaller, and you need to optimize that one GPU you probably have on your laptop. And, buying a $3,000 laptop versus renting an instance that's running at 75 cents an hour, you start doing the cost benefit analysis and going, I can do a lot of training here. And you start talking about more complex workflows. And all of a sudden, as you start building out your machine learning model development workflow, you start realizing, okay, if I really want to do a ton of model comparisons, if I really want to understand why this one particular model performs well and prove that it's better versus this growing library of models that I've built up, and some of them I've customized, other ones I haven't. If I really want to prove that this is the best one and this is the one that we should throw into production, now all of a sudden cloud makes sense. And making that transition off laptop, off prem, it all of a sudden, like I said, you're talking about value, you're talking in real numbers. Why? Well, I've got this workflow that's going to choke my laptop, and it's going to take 4 days, or it's going to take 17 hours.
Mm-hmm.
And all, like I said, it's those numbers and it's those conversations when people get used to, it would cost this on my laptop, or we've got a couple servers in house, but we could probably use them in a smarter way. So if I throw this off prem, there's no downside and it costs less. You're having that smarter conversation, and there's no resistance to going to the cloud at that point. Why are we going to the cloud? It'll save me 3,000 on this project. Okay. Why are we going to the cloud? Well, long term, this will save us 125,000 in labor. Okay. It's a whole lot easier to go to the cloud when you know why.
You bring up a good point too with the skills gap earlier too, because things I see is for the companies that haven't yet gone to the cloud, your IT team might be reluctant, right, to hand over those keys, and so yeah, even if the data scientist wants to go to the cloud, you still got to deal with an IT team that's typically going to be the gatekeeper anyway. I can't think of a scenario where a company is going to just randomly let a data scientist, just spin up stuff, throw company data into the cloud, and they'd be fine with that situation.
Surprised how scary some of this stuff is.
Oh yeah, I'm sure it happens, but it's definitely one of those things where you're like, yeah, I think there's a lot of rogue cloud stuff. So, I know that the IT teams I deal with for sure, they're like, nah, as far as we're concerned, we're gonna keep control of this. And I guess that does kind of lead to the rogue behavior that maybe you're indicating. So,
and
it's interesting.
When I come into a new project and it's a company that's got that sort of framework where you have IT and all my machine learning resources sit under IT, I show an invoice for three days worth of my time while I was waiting for a GPU instance to spin up. And I got the line item, watching Netflix, waiting for GPU instance to spin up. And all of a sudden IT loses control because it's so expensive to have 3 data scientists waiting for half a day or a day, or having a project delayed 5 times, for 4 hours each, because we were waiting for IT resources, because we were waiting for IT to be able to spin something up. And that's when machine learning engineers show up, because you can justify the cost of an ML engineer who can handle all of this, who can create a really simple package for data scientists who don't understand spinning up cloud resources to spin up cloud resources on demand, have them come up, come down, no wasted bandwidth, no wasted CPU and cloud resources. So that's the justification for ML engineers in a lot of cases.
Mm-hmm.
We're moving it out of IT because it's inefficient, but somebody else has to manage it because data scientists don't really know enough to do it.
Yeah, yeah. And thank goodness for the ML engineers too, because to your point too, with the cloud, right? Like data scientists not knowing how to do the cloud, like not knowing, just basic like security, permissioning stuff.
Yes.
I mean, the horror stories that we'll sometimes see is like S3 buckets that are public, EC2 nodes that are like, uh, you know, the ports open to like 0000, and just that kind of
Mongo
stuff.
instances with 00000 password or admin.
Hmm. Well, I think I don't know if there was some paper or some article that talked about that actually. There, like the number of unsecured Mongo instances out there. It was a few years ago, but it was mind-boggling. Not sure if those were production instances or not, but like that
They
number should
were.
be. Oh, yay.
Yeah, they had corporate data, personal, individuals data. It was, and it's still up there. I still go into companies where there is a Mongo instance on somebody's desktop and it's running default port, no password protection at all. Anyone in the company can just roll into it.
Wow.
Yeah. Yeah. The other one I see is downloading.
Mm.
Some data scientists will download anything. You send them a link to a .ru website and they will click on it, go straight to it, and download anything that you tell them is an amazing data set off of it, and then use it in a model and trust it.
Oh, wow.
That's amazing.
Huh.
I mean, think about, people, especially in at the college level, who've done that, and that's where the behavior starts, is in college. People are used to going online and finding their data for a project, or being told by the professors, yeah, you can just go here and download it off this one repo over here. So you get into the behavior of doing that. And if your company doesn't have like a hardcore infosec team, you keep doing it. You spend the first 3-4 years of your career and never getting burnt by it. So what's the big deal?
Mm-hmm.
And unfortunately, it's a worst practice that just gets reinforced.
Hmm. Yeah, it's interesting, and I'd say the complexity of the cloud also doesn't do many favors, right? Because if you go to Amazon, for example, AWS has how many products now? I don't know.
Yeah.
I remember I was at a talk with Jeff Barr once, the evangelist for AWS, and somebody asked him, "So do you know all the products in AWS?" And he's like, "I certainly don't. I don't know very many of these at all. There's too many to count or understand, and there's always new ones coming out. So I mean, if and I think he's been with AWS since I think almost day one. So if he's having trouble, and if other people at AWS I talk to, if they don't understand the ecosystem, um, how are you, a data scientist, going to understand all that, right? It's so what I typically see is like a mismatch of products. Like you go in and you'll see like maybe a certain
Yep.
product being used in a very unnatural way, and so yeah, the things I'd recommend if people are going to go to the cloud, like definitely understand how that cloud wants things to be done. Like don't try and force your opinion on it, because it's makes some pretty expensive mistakes and probably catastrophic mistakes too. Like downloading stuff off a .ru site or something, or far worse. So
Yeah, and the other thing about the cloud is that it's part of this skills creep for data
mm,
scientists, where we're supposed to, it started off, you just had to know a little bit of programming, a little bit of database, a whole lot of math, and a whole lot of the theory underneath it, and you were good to go. Then you needed to know Spark, and then you needed to know a whole ecosystem of platforms. Then you needed to really understand cloud. Then you needed to understand a couple of different programming languages, several different databases. Now you need to understand services and how to deploy, how to support in production. And you hear this scope creep, and that's not even to mention like 5 years worth of research papers trying to figure out, in the field, splintering off. It used to be if you knew natural language and computer vision and some reinforcement learning, you're pretty good. But now, the number of different niches that are out there, it's the skills creep.
oh yeah,
And cloud's a huge part of that. But the assumption is still you're a data scientist, you know everything. It's just not, it's not possible.
That's so true. You know, even on the for the audience, like Vin and I are sometimes in Harpreet's office hours, data science office hours, and it's interesting because I think the question from a lot of these data scientists comes up a lot of cloud related stuff, and thought about giving a cloud class, but I'm just I'm like, well, where to even begin? You know,
Yeah.
like the
Which
stuff I
cloud?
probably actually hit on is like I the thing I'm thinking about is just like even just going over IM and security for an hour because like that's the stuff if you think about what's going to screw you up in AWS like roles and permissioning is typically where you're going to get stuck. That's even where I see even hardcore cloud users get stuck regardless of the cloud. It's always permissioning. Like this doesn't work because I don't have it configured properly. Um,
Yeah.
so
Yeah, the permissions and configs. Yeah,
it's
that's
but
true.
it would be something like super mundane like that, not like here's how you spin up a giant GPU cluster in the cloud so you can do your modeling. It's like I think so I look back and it's like does it seem like really underwhelming, like super lame? I don't know. So, but
Well, I think
it's important.
that's the impression of it. Like everybody has the James Bond impression of the cloud, where they think that I've got my hoodie on and I've got eight screens in front of me and all of them running terminals. I've got two different flavors of Linux and I'm running a Windows one just because I'm lazy. And yeah, no, it's not like that. it's, it's me in the console trying to figure out, okay, do I have an instance that do I already have like yeah, I think I already have I have an instance that I can just spin up already. I can just start that. No, I really need to build up a customized and add this one little thing. That's cloud. That's it
Yeah,
right there.
yeah, that's cloud. Then there's like the of your three monitors, like two of them have Stack Overflow links, opened up as well. So, like,
AWS introductory tutorials off to the
yeah,
side.
not even kidding. I
Yeah.
mean, it still happens to me once in a while too. Just like basic shit. Like, I mean, because it's a skills creep, right? Like, there's so much to know, and even like if you know something, you're still going to forget it.
Yeah.
And just because there's too much to know. So,
And I was building containers, and one image that I was building was this was a few years ago. It was a TensorFlow serving an extended stack, and I was so into all of the more complicated sides of it, I forgot Python versioning. Like there was a mismatch between what TensorFlow extended supported versus just TensorFlow
hmm.
supported. So they supported two different versions of Python, and we had to change the version. I mean, it's something that simple, and I was staring at all of the other crazy complex things I'd forgotten when I had this version. When I had my version sheet, it was, I had forgotten to sync up the Python versions and stuff like that. When you're building containers, oh, yeah.
Happens to the best of us. So, I think I was going through that in Conda a few weeks ago. I was updating they got a Mac M1. I was updating everything, and um, yeah, and I realized, yeah, same thing. TensorFlow,
Yep.
depending on your Python version, won't install at all, and on mine didn't at all. And so I think I was running Python 3.9.
Okay. Yeah. Yeah.
Yeah, and it was like, well, there you go. So I'll just use PyTorch instead. so, so that ended up happening. So, I mean, you work in machine learning engineering. What are some of the big trends that you're seeing over the next few years?
I think it's causal. Like I did something this morning talking about causal, and there's some work to be done on it still. There's a lot of challenges. And I think when you talk about causal ML, companies haven't done enough of it to have an idea of what a standardized toolkit would look like and what an architecture for causal would look like. And developing it, the research side of it and the experimentation side of it is so much more labor intensive than putting it into production. And it's almost like ML ops is going to flip.
Hmm.
And you're going to go from these models that are extraordinarily complex to manage to models that don't drift as much, to models that don't have all those problems in production that we kind of band-aid with ML ops platforms. And so you're going to see now the support from for the research, because the research is going to be stupid complex in order to do causal modeling. It's hard. these experiments are sometimes, and to figure out how to do an experiment when you can't get as much data as you really want to, you can't observe half of the things that you need to observe in order to really do this the easy way. You have to go through so many layers of obfuscation and gather data in a really rigorous manner. And these pipelines become so much more critical that, yeah, that's what I see. It hasn't happened yet. But that's what I see happening, because the more that I work in that causal space, the more I'm seeing like that's the front end's way harder. And what you get out the other end is a completely different product, and it's totally different to support. And so what you're going to need at both ends are, you know, that all these things that you have on the back end for models now are going to have to shift resource wise to the front end. So that's what I see coming for ML ops, is sort of this, we bought this huge stack for the back, and now all of those vendors are going to start saying, well, and now we also support. And so there's going to be this upsell. Some of them are going to do it clumsily, you know, and you're going to be stuck with this legacy ML ops architecture, not seeing causal coming, because it's still 3 to 5 years from mainstream, at least in my opinion. Maybe it's faster than that, but I think 3 to 5 years away. So it's not on everyone's radar. And it's going to be one of those surprise bills, like, and you need to buy. So I think that's the biggest challenge for ML ops, is we're going to have this great architecture created, and then the way that model development workflows happen is just going to flip. And it's going to require a different type of adaptive stack that's so much more front side focused and research focused. I think it's going to hit talent too.
Interesting. How so?
Well, your ML ops engineer is going to be fairly resilient from a skill set perspective, but your data scientist isn't. Most data scientists are very, I don't know, more software driven, software development driven than model development driven. And so what they're used to working on is really the simple process of developing a model, but building something that's monetizable, building something that actually creates a competitive advantage is all this research. Research is where your cash comes from, because it's going to create artifacts that are useful through multiple projects and become sort of this competitive advantage for the business. Data scientists don't do that by and large. You know, there's this research, ML research community that's very small. And then you look at how many are on the applied side and actually build for business, build for production, and that's even smaller. So we have this large retraining that we're going to have to do here over the next few years to teach more rigorous model development.
What are some resources that you would point people to I guess, get a better understanding of causal machine learning and causal modeling?
Unipearl. Just follow Unipearl. And he will basically break off everything you need to know and give you that answer way better than I can, because I'm kind of this, like, I understand it well, but I'm not smart enough to teach it yet. And I'm still sort of figuring out my filter of what's a quality resource versus what's a, maybe that's promising, but not that great. You know what I mean? How most of us are when we look at research papers early in our career. You look at it and you're critical and you understand it, but in a lot of cases, I'm looking at work on causal and saying, okay, that sounds awesome, but how do I know it's awesome? And I'm still figuring that piece of it out, trying to understand what's going to go someplace and what's interesting, but I'm going to have to fill in a lot of the blanks myself.
I don't think you're alone there. I know in his book, like the Book of Why, when it came out, like, was it 2018, something like that? I know a lot of data science directors were reading that, right? And trying to like figure out, okay, so in this mental model I have of data science, where does this fit in, right? Because deep learning is the rage right now. You know, maybe capsule models or whatever the hell is going on, but and then you come along and talk about causality, and it's like, okay, so this changes a bit.
It changes, yeah. Quite a bit. All of a sudden, what we do, you know, in supervised learning is kind of like, in my opinion, I don't know if this is actually going to happen or not, but this is pure opinion. I think supervised just gets chucked. I don't think we can keep much of supervised learning in the causal paradigm. Like, I don't know that you can trust labels well enough to say that you have a quality data set which covers your ontologies completely, because I don't see one ontology being relevant across multiple problem spaces. And I don't, and so there's kind of these deeper, they almost sound philosophical, but they're really at the heart of labeling and how we label data and how we use labeled data to represent some sort of a system. And we always seem to have, at just every step, there's a problem. And so you're right, it's totally different. And it might toss out one entire branch of our field.
It's interesting. It's an interesting prediction. I mean, especially when you're talking about kind of tabular data. I mean, that data is notoriously hard to work with in supervised learning. So, like a friend of mine, he's he's a math professor and has been working on even just a totally new approach to dealing with just like the non-linearities of like a data set, right? Because it's not like structured data is like hard just because each field is different. It's not like an image or something where there's like some sort of coherence to it. Like structured data, depending on how you structure your columns or what you choose to add or not, it can produce some like very strange complexities in the training for supervised learning. So, but it's one of those things I think people just take for granted, right? So that they're just like, oh well, I'll just throw like XGBoost at it because that's like works pretty well and stuff. So.
Yeah, I'll just throw feature engineering at it. I hear that a lot, and it's like, what does that mean?
Right.
You really know what that word means, or those two words mean? I know you said it, but do you really understand those words?
It's hard. Like, good feature engineering is really hard.
Yeah. And you bake so many assumptions into your model right there. And the concept of, getting back to MLOps a little bit, the concept of a feature store is so scary to me because you have assumed that this feature that you've built is good for your model, and you may have some evidence for that, but in a completely different setting for a different model, for a different business case, modeling a different system, that assumption that you baked in that isn't really documented any place in the feature store, probably not going to hold true universally. So somebody else may look at it and say, oh, proven, grab that feature, and now there's an assumption baked in they don't even know is there. And so they're having error brought into the model and trying to find the source of that. It's a nightmare. Feature stores I love the idea.
Mm-hmm. Yeah, they've gotten really popular all of a sudden. It's been fascinating. In fact, at my upcoming Utah Data Engineering meetup in April, I got William Piniar from the author of Feast giving a talk on feature stores. So
Nice.
It's one of those things where, yeah, I think you bring up a very valid and I think very, I would say contrarian view, which I do appreciate a ton, because it's like, because right now there's a ton of attention on feature stores, and it seemed to have somewhat come out of nowhere. Like I remember talking to the Tecton around was it May or June of last year when they first started, but what I find interesting is that I can't remember what podcast it was. I think it was Twimmel, but there was a discussion about feature stores, and the only thing I could take out of it is nobody could actually describe what a feature store was consistently. So, so we'll see where it goes. I mean,
I hope we solve some of the problems that we need to with features using something. I just don't think. I think feature stores are step one. And I think we have to make mistakes with feature stores and find the mistakes, and then maybe we can start figuring out a better solution. I mean, I don't have one. I'm not trying to play the sage at this point, because I don't have a solution to feature stores. Because we need them. You need something to make your model development lifecycle reproducible. I mean, somebody else has got to check my work. They've got to be able to reproduce what it is that I've done. And if we don't have a feature store, you can't versionize those things. You can't versionize the data that you used, and there's no reproducibility there. But at the same time, like I said, you propagate error, you propagate assumptions. There's no documentation to, how'd you do your feature engineering? Who did it? Did the intern do this? Who?
Well, what's interesting is I think anyone who's done production ML has actually built a feature store almost on, either intentionally or because it was somewhat necessary. Like you got to save your features somewhere. hopefully, unless you don't care about that, then
Let's
shame
hope. Let's hope.
So I think you got to retrieve them though, right? And then because you got to figure out when there's going to be like drift and other kinds of stuff. But yeah, it's interesting too because I think there's there's a vertical of feature stores which is becoming something. Not sure what it is. Data quality is becoming another one, and bias detection are like two sort of parallel niches that are tracking a lot of, and observability is another one. I mean, I can think of like at least 6 companies in that space alone, all startups. And what I find fascinating, I talk about this often, is like it's just interesting seeing all these ML ops and ML engineering startups right now. They're all founded by like very bright, very successful people, and typically they're backed by great VCs. And given all this, I personally have no idea where this shakes out. Who's going to be the winners of these categories?
I think it's all under the umbrella of reliability, model reliability. And that's what's going to drive, in my opinion, causal, because all of this architecture is expensive. All of what it takes to really run models in production that suck is expensive. And as you improve the quality of your model, the amount of money it costs to support it comes down dramatically.
Right.
And as you begin to improve your workflow, the amount of money that it costs to deploy a model, the amount of money that it costs to develop it, all of a sudden starts dropping. So doing things right, it's cheaper on the front end and it's cheaper on the back end. And that's where I see like us getting pushed into causal, is because that's really where you get a higher quality model faster, and that ends up being way cheaper in production, because now you have something that you have a high level of certainty on. It's very reliable, and you know where the areas that it doesn't work are, because that's, you're never going to have a perfect model. It doesn't, causal doesn't matter. We're never going to have perfect models, and so we're always going to have some cost to support it and some cost to continually improve it. But what causal can do is tell you where that cost is going to be, what areas and what situations your model is going to perform unpredictably in. And so you can reduce the cost of supporting it, because one, either you're going to improve that area, or two, you're just going to say, don't care if it falls apart in that scenario, I'm going to just put something else behind it and call it good, so I don't have to support that. And I think that's where we go. But you're right. How does this shake out? What does that even look like? From a support standpoint, from a ML engineering skill set, you're still going to be supporting platforms and architecture, and they're still going to be doing a lot of the same processes, just switching more to the front end.
Mm-hmm.
So your skill set as an ML engineer is pretty resilient. But
yeah, it's just kind of the order of operations, I think, is what you're saying, right?
Yep.
So yeah, it's interesting too, because in the big clouds, for example, right? Like I know AWS reInvent, they announced a bunch of new MLOps tooling, most of which is pretty cool, actually. They have their own feature store now, and data wrangling and all this other kind of stuff. But yeah, what I find interesting in your comment about causality becoming more front and center is I'll be curious to see where the clouds go with respect to causal models, right? Because every cloud has their own quantum computer, for God's sake, right now. Like they're thinking of like kind of left field stuff.
Yeah.
So where's my causal, damn it? So
well, I think, like I said, I think if you're Amazon or one of those big companies, you're looking at ML ops right now the way that we're talking about it, where you go, I don't know where this is going to go. Why am I going to invest a ton of cash in building products that are massive and robust and everything else when we don't know where it's going, what it's going to do in the next 5 years? Mm-hmm. How do you build in front of something like this when companies just aren't there yet?
Right. Yeah, and there's still a lot of room to grow. I mean, like you said, the kind of looking back earlier, it's the big companies that have adopted ML. SMB, that still remains to be seen. I know a lot of the tooling's there, but but at the same time, there's all these competing like point solutions from third-party SaaS and so forth, and it's all of which are built in the cloud. So I don't think the clouds really give a shit one way or the other. They're going to make money. So it's a matter of like, I guess, when you start competing with the cloud. It's a fascinating thing to watch always. I have no idea where it shakes out either. Like I said, and I talk to these companies too, and and various people in the industry. I'm just like, I just don't know that I'm smart enough to know who the winners are. So
Well, and I think
it's like,
big companies like Amazon are just, their strategy is buy them,
yeah,
because think about it. If they spend, over 5 years, if they spend $4 billion buying companies, who cares? They don't care. Yeah, that's not enough money for them to really be worried about. So for Amazon to say, build by themselves, they'll probably build a framework and they'll build a small competitor to something, but their
hmm,
strategy is just going to be, whoever comes out on top, I'm going to buy them. If there's any sort of threat to my competitive advantage, or I'm going to use my size and scale to just build it faster and build it better
hmm,
and outcompete. They're at a place right now where it would really take something significant to push them off when it comes to cloud. Same thing with Google.
oh yeah,
It would really take something significant to push them out of the way.
yeah, yeah. It's interesting. And then you could always take the snowflake approach, which is just um, spend a lot of money on the clouds, and
Yeah.
then it's kind of for the clouds, it's kind of like heads I win and tails I win, I guess too. So um, yeah, the whole competitive effects are. I think a lot about this kind of stuff with the third party vendors in cloud. It's fascinating to watch and yeah, interesting. So anything else in your mind with ML engineering?
Not really. I think we covered it pretty broad. I mean, I think we went from one end of the spectrum to the other.
Yeah, yeah.
I guess I would say, like, I'd ask you a question. Like,
Mhm.
what's the one tool right now where you say it doesn't matter what you're doing, your stack's probably going to not, 100%, but no matter what you're doing, your stack's probably going to include this now or very soon.
Hmm. A pedestrian answer, probably some version of Linux. I don't know. I mean, it's like, um, yeah, that's a tough one. What do you think?
I don't know. That's why I've asked a few people this question, and it's one that I don't really know. But when you talk about trying to skill into a field,
Hmm.
people will ask me, how do I become an ML engineer? And I can give them
Mm.
bits and pieces. But when it comes to platform, they're like, what platform should I learn? It's like we talked about. How do I answer that question? I don't know.
It's
You're
interesting.
going to be learning a lot. So where do you start? And that's a question I struggle with.
So I thought about this a lot with data engineering, and I think the answer that I give is you need to understand the data lifecycle and the different pieces of it, and then I think a lot of things take care of themselves from there. Like if you understand the different paradigms of ingestion, actually, if you start from source systems, so how do source systems generate data? What types of data do they generate? And then start working down the progression all the way to like the doing something category, where it's like I'm going to do analysis or I'm going to do machine learning. That's typically how I advise data engineers to think about the same kind of question, like how do I become a data engineer? Because at that point, then it gives you, I think, an overarching framework to kind of understand holistically how data flows. Because a data engineer, my definition of it at least is like, you take the raw data ingredients provided by analysts and machine learning users, right? And that's about it. So, but in terms of the single technology, like I said, I half jokingly said like some version of like Linux or Unix, but I think that actually underlies everything as a primitive, unless you're in Windows,
Yeah.
which you might be, um, but even then, like even in Azure, like Linux, I think is like the top seller for servers. So, um, but yeah, it's a tricky one. But yeah, I would say like if there was a universal skill set to know along any part of the life cycle, we're talking data engineering or ML engineering, it's probably the command line actually, and just knowing how everything works, because everything
Yeah.
runs on that system. So
Yeah. Get used to typing commands. Yeah. That's
hmm,
true.
yeah, because even if you're running Docker, I mean, you're
Yep.
still running Bash, and even if you have to install Python and TensorFlow, extend. Just kidding. Um, still gonna be doing like a pip install or something, right? So
Yep.
or a conda install. So yeah, I don't know. It's a good question, but I mean my spontaneous made up answer is probably that one. So It'd be fun to revisit this, though. Maybe we'll talk about it tomorrow more.
Yeah.
So, the office
Well,
hours.
talk about it in 2 years.
In 2 years, yeah, right.
See
Yeah,
what the
but
winners
but I
were.
try and look at it, through the perspective of like, do you know what the Lindy Effect is?
No, I don't think I do.
So the
No.
Lindy Effect is basically this notion that there are certain mainstays in a field, right? So in technology, something like Unix and the command line. It's basically the notion that the longer something's been around, the longer it'll continue being around. And so things like SQL, I would say, fits the Lindy effect, where like that probably isn't going anywhere for a long time, no matter what happens. Like databases, relational databases probably aren't going anywhere for a really long time because they're such a mainstay. So I tend to look at these, I tend to answer these kind of questions from a viewpoint like that. Like what's immutable? Like if you take out the language wars going on, which is like Python's hot now, I have no idea where it's going to be in 10 years. I'm sure it'll be used because it's used everywhere, but is it going to be like the language of data? I'm not smart enough to know that. But I think I am smart enough to know that the underlying system isn't going to change that much. You're not going to change Linux like that much because the whole world runs on it. So
Yeah, I think we're gonna be talking about SQL in 10 years, like Fortran, where you just, it's there. It's inevitable. It's not going anywhere.
it ain't going anywhere, man. I mean, I'm sure you remember too, back in the early 2010s, late 2000s, the rise of MapReduce and
Yep. Yeah.
SQL is gonna, and all these NoSQL databases coming out, right? I mean, SQL is written off for dead. Like, oh, you don't need to know that anymore.
Yeah.
Yeah, I mean, guess what? Like, Spark's got like Spark SQL now. That's data. It's just a data frame is like a first class citizen, and then this sudden rush back to like cloud based data warehouses, I think, is another evidence, right? Where um, I'm personally seeing a lot of people just move away from Spark in general and just going to Snowflake or data warehouse or BigQuery, just because it's like, why do I need this extra overhead when I can just put my data in here and just query and be done?
Get
So,
straight to it. Yeah.
so who knows? It's we'll have to revisit this often. So maybe we're both wrong. Who knows? So,
Yeah. The best guesses are mostly wrong, but have that one grain of truth in them that I can hold on to and say, look, I was right.
yeah, yeah. Well, I mean, yeah, I think you and I both shared some early skepticism of machine learning. I think early on in the early 2010s, and I think
Yep.
that's informed both of our careers, even though we didn't know each other back then. It's like I think we're both like very on. It's kind of funny like, meeting people like us coming out of the woodwork because it's like we were all on these like kind of these lone trails, so to speak, and
Yep.
now so well, cool. Vin, it's been good talking to you.
Yeah, good talking to you too. Thanks again for having me. I
Yeah,
appreciate
of
it.
course. Yeah, we'll have to do this again sometime. So I feel like we can talk
Definitely.
for a while. So cool. All right.
All
Have a
right.
good one.
Thanks. Have a good
All right.
rest of
See
the
you.
day.
All right. Take care.